doesn't really matter at all. 9:45, here we go. Let's do some gram problems. Mole and gram. Okay. Good morning, Yo, and Coco and Brooks. Brooks, Joy, Notar, Coco. Thank you for being there. Good morning, Lisa and Remy. Good morning, Stephanie. And good morning, Tilly. While we're gathering up, I'll just tell you I was watching a video just before this, a live video of the volcano in Iceland erupting in a snowstorm. Anyway, it was kind of cool. So if you want to see something neat, not forever, but for a few minutes, watch that video on YouTube. It's a live video. They just have it set up on the erupting volcano in Iceland. It's kind of neat. Okay, let me get some other folks. Good morning, Frederica, Emelina, and Aaron. And there's more already. Good morning, Tully and UCM. Terrific. Thanks, everybody, for showing up. And there's Keanu. Hello, Keanu. All right, you guys are quick today. Let's see. I'm still looking for Mick Burns, for Jonathan, Marino, Julius, and Jordan, Emil, David, and Matthew. So if any of you are there, please give me a heads up. Yeah, anyway, the volcano was pretty interesting. You could see the glowing orange, and then once in a while it would kind of flop out some lava. You could see it flowing in front of the crater as well. And a lot of steam coming up, of course, as well, and snow flying around. So it's still cold even if it's hot. So, but kind of interesting picture. There's Emil. Today, so you know what we're doing. We're gonna just warm up by I'm sorry, I'm still thinking about the volcano. We're gonna warm up by balancing a reaction, doing a mole problem to remind ourselves how to do that, and then start something new, which is to do a gram problem. So that's gonna be our day. Let's see if I can get a few more of you here before I start. I'm still looking for Mick, Jonathan, Marino, Julius, Jordan, David, and Matthew. Any of you out there? I'm going to put up the equation and see if you guys can balance it. Ready? We'll check those folks in if they come a couple minutes late. Okay, so we're going to do an equation where we're going to burn pentane. Pentane is a fuel you'll study in 9th grade. It's not in gasoline, but it's also a liquid, kind of like gasoline. So I'm going to say pentane. I'm going to give you the formula, C5H12. Burns in air. Reaction? I'll start you off. C5H12. That's a 5, not an S, okay? C5H12, and that's a liquid, plus forms and Okay, whenever we burn stuff with C's and H's, we always get the same stuff. See if you can remember what that is from last time. And if it's burning in air, what's the key ingredient in air that will be there? Oh, and I got a comment already from Remy. Let's see. She's got a question about mole problems. Is it possible to use proportions while doing these kinds of problems? Yes, Remy. In fact, there's a proportion in the middle of each problem. You can also use proportions as such. The reason I didn't teach you that, Remy, is because of what we're doing next, which is gram-gram problems. So, yeah, but you can use proportions, but when we get to the gram-gram ones, then you can't use proportions anymore because they don't work. And that's what we'll start today. They're a bit longer. Okay, I got some comments from others, and thank you. You are right. So Lisa and Stephanie says oxygen. So oxygen is O2 gas. And they got a question. Who are they? They have a question. Yeah. We answered Remy's question already. Okay, so okay, so what's formed? Okay, if I burn this thing with C's and H's, what formed last week when we did that? We did a similar reaction. So give me the two common chemicals that form. You know both of them because we've talked about both in class. Just look at the elements that are in them, and you can probably guess anyway. They're really common compounds. And sorry, not elements, compounds. They're very common compounds. So what and what form? It's okay to guess. Okay to guess. In the meantime, anybody else out there still looking for Mick, Jonathan, Marino, Julius, Jordan, David, and Matthew? Any of you there, please say hi. Yeah, super. Thank you. You guys are, oh man, everybody got it. Good. So Brooks, Tilly, Lisa, Stephanie, Aaron, yeah, great. UCN. Thank you, everybody, for participating. It is indeed those two. It's water vapor, H2O gas forms. And the other one, not such a nice thing to form, is CO2. Not so good for the environment, but you and I make lots of CO2. Even when we exhale, we give off CO2. You knew that, right? So those are both gases. Now, I need some help from you. And let's make sure I didn't miss anybody. There, I got a Julius. Julius is here. Thank you, Julius, for checking in. All right, better late than never. Let's go ahead and figure out. I want to balance the H's. How many waters do I need to balance the H's? So punch in there, please. How many waters do I need? Everybody take your guesses. How many waters do I need? I know there's always a little lag time, so I got to wait to see your responses. I'll get as close as I can so you can see it. C5H12 is the front chemical. So how many waters do I need? I got some guesses already, and the guesses are correct. Yes, from Lisa, from Remy, from Stephanie, Yo, Emelina, Coco, Tilly, and UCN. 6 is correct. Good. How many CO2s do I need? Your starting chemical C5H12. How many CO2s do I need? And Tully and Aaron had that too. Thank you for participating. It's nice when I know you're all awake out there and jumping in with the chemistry. Okay? How many CO2s do I need? It's C5H12 as a starting chemical. And again, I bet I'm going to get all your responses all at once. They all bunch up in the internet, and then suddenly I get them all. Boom, and here they come. And UCN says 5 with a question mark. Let's see if some others agree with her. Well, your question mark doesn't need to be there. 5 exclamation point UCN. It's correct. There's Tilly, Lisa, Stephanie, and others now that get that. as well as Remy, Emelina, Tully, and Yo. 5 is correct. So I got 5 CO2s and 6 H2Os. Good. We got to do the oxygen now. Remember my rule? Do the diatomic one last, right? Do the Brinkelhoff last. So we're going to wait now. Well, now we're going to do it. Okay, let's count O's. So I got what? 6 times 1. So I got 6 O's. I got 5 times 2, 10 O's. So what number do I need here in front of the O2? David is here and Marino, but they need to kind of say, oh, there's Marino. I see him. David, you want to say hi so I know it's you there? That's David. Thank you. Thank you. Although it's better if you just say hi on your own, David. Okay, I got David here. I got Marino. Thank you for being here. And I need the number in front of O2. So if you're just arriving, how many O2s do I need if I got this many O's over on the product side? Yeah, super good. There we go. So, right. Yeah, so I don't know what's going on. Maybe do the rest in a class chat. Okay. 8 is correct. So 8 is correct. So here we go. Now we're balanced. Okay. All right. So let's do a mole problem to kind of warm up. So this is review. I hope I haven't graded your homework yet. I will over the next couple days. And let's see if you can still do them. So I'm going to make up a mole problem. And it's going to be this. If 0.35 moles H2O formed, how many moles of CO2 formed at the same time? Let me read that again in case your reception's not that good. If 0.35 moles of water formed, how many moles of CO2 formed at the same time? Let me see. Thanks, everybody, for responding there with oxygen. Let's remind ourselves how to do this. While students are learning, like in 8th grade, I suggest a plan. The plan is pretty simple here. You just take the label you were given, the Einheit you were given. We were given moles of water. Plan means I don't put any numbers, just the labels. And you're trying to get to moles of what? What do they want in the question? What's the other part of my plan? Moles of water going to moles of what stuff? Just so I know you're out there and understanding how to do this. What am I asked for? Thank you, Stephanie and Lisa and UCN. They asked for moles of CO2. And remember, I can abbreviate mole to MOL. I know it doesn't save you a lot of time, but that's just the way it is. Thank you, everybody. Marino's there participating, as is Aaron, Brooks, Emelina, and Mick is there. Mick, you're a little late. Let's try to be on time, but I will mark you down, Mick. Thank you for checking in. Thank you for checking in. Okay, CO2 is correct, everybody. So let's now do the problem. Now we're actually going to start with the number. Remember how this went? So we're going to go 0.35 moles of O2, moles of H2O. And then this arrow becomes a fraction. And so I want to get rid of moles of H2O. I'll put that on the bottom. Just like in math class, to make things cancel, like 4 times 1/4. And then on the top, I want the moles of what I'm trying to get to. So that's going to be moles of CO2 on top. Good. And that's it, except I got to put in some numbers. So, my people, listen closely, and then you can type in your answer. What number goes on the top? What goes on the bottom? So give me your two numbers. Top is what? Bottom is what? So type in your two number guesses. Top is what? Bottom is what? CO2 was right. Thank you, Emil. So what's the top number? What's the bottom number? Good. I got a couple guesses already. I want to give people time to respond. All right. And looks like I'm gonna take some of those already from David. I think it is. I got the moles of H2O. He's 6, and he's pulled that right off the balance reaction. That's correct. And I got so many of you. I'll just say UCN and Stephanie, Lisa, Emelina. Emelina says 5 at the bottom, 6 on. No, Emelina, 5 at the top. Let's see where she got that. 5 at the top. Yeah, it's 5 CO2s. Thank you, Emelina. Everybody, good. I'm glad you can do that so easily. So now you've got to find a calculator. You need that for the rest of the hour. Can you look around your room and grab a calculator, please? I need you to do this for me. 0.35 times 5 and then divide it by 6. And then round your answer a little bit and let me know what we get. So can you do that math? And then let's see if we all can get the same answer, okay? So type in your answer when you get it, and I'll put it on the screen, and we'll see if everybody agrees. See if everybody agrees. 0.35 times 5 divided by 6. Okay, and I see Jonathan is there. You're a bit late. How late are you? Yeah, you're going to have to watch the first part of the video, maybe. Okay, Jonathan, I have marked you down. And I got lots of answers from everybody who's been here. Thank you for doing that. And looks like everybody agrees. So they got 0.29, and that sounds just perfect. 0.29. And some of you even had labels. Thank you very much for doing the labels. Moles of water cancels, and I end up with that's moles of CO2. That's a really typical mole problem. Notice that it involved two chemicals on the same side of the reaction. It doesn't matter. Long as I know the numbers that are in front, called the coefficients, I can ask about any of these. I could have said how much C5H12 burned. I could have said how much O2 reacted. You know what I mean? So you can make up your own question, mole questions. But if you can do that, we're going to go on. Any questions about the mole type of problem before we do something different? We're going to use the same reaction, but I'm going to change the question quite a bit. Judging by the responses, I'm guessing everybody's there. Thank you. Thank you, Marino, Keanu, David, Brooks, and everybody, Stephanie, for participating. Okay, here we go. Let's make a new question. You ready? Okay, I think you're all doing fine. If you understand this stuff, that's good, because it's going to get a little more interesting now. Okay, so here we go. If (422) grams of we'll just do pentane, C5H12. If 422 grams of C5H12 burn, how much, and by much, if they say how much in chemistry, they mean grams, okay? They don't mean moles. So if how much always means grams, how much CO2 forms? So the only thing we've changed in the type of problem is instead of moles, now this is called a gram-gram problem. You know what, though? It's a bit longer. Let's make a plan, and you'll see how to do it. Here we go. Plan. This time, my label I'm starting with is not moles, it's grams, and it's grams of C5H12. Yeah, we've got to first change that. Well, okay, here's the problem. Here's the difficulty, okay? The difficulty is this equation is not written in grams. Let's just check that and verify that. What if it were written in grams? 1 gram of this plus 9 grams of that makes 6 grams of this plus 5 grams of that. 1 plus 8 grams would be 9 grams. 6 plus 5 is 11 grams. That doesn't make any sense at all. We know that, right? Because equations are not written in grams, they're written in moles. So, problem, I've got to change first my grams to what? In fact, here I'll say my grams of pentane, I got to change it to what first? Before I can use this equation, I've got to change my grams of pentane to what label? I'm looking for a label, not a number. Super. I got to change it to moles. Specifically, I got to change it to moles of pentane. So moles of C5H12. You might say, Mr. Weiss, that's the only stuff I got. I like to put the whole label on. No, not me. All chemists do, because we got several chemicals floating around here. So we can change it to moles of C5H12. Again, that's a 5, not an S. Then we can change it to moles of what we want. Everybody, thank you, including Coco. Changing grams to moles is exactly right. Good job. Good job, Julius, too. Okay, so now I got it changed in my plan to moles, and now I can change it to moles of what I want. Okay, and what is that, folks? I want to go to moles of what chemical? What do they ask for? This is just to see that you're following, okay? We're going from moles now of C5H12 to moles of what stuff? Okay, thank you, Stephanie, Lisa, Tully, and a whole bunch of others. It's very good. And Melina. Okay, moles of CO2, because that's what they want to know. Well, not quite. They want to know how much in grams of CO2. Oh, man, so I'm still not done. I got to change my moles of CO2 now to the question, no, not now to the label they ask for. They want grams of it. How much in grams? So my end of my plan looks like this. I got to change it to grams of CO2 at the end of the day. Okay, now. Here we go. You see these arrows? These are really useful. Check this out. I got 1, 2, 3 arrows. What that's going to be is 3 fractions to help me do this. So to put a long story short, Remy asked me earlier if I could use proportions. This is why I can't very easily, because my plan now has gotten fairly complicated, but it's doable. You'll be able to do this, okay? I'm going to do the first one with you. Here we go. So we got 422 grams of C5H12 Then, again, that's a 5. I'm sorry, my 5s look so much like S's. Then it kind of goes like this. Each of these little arrows, 1, 2, 3, becomes a fraction. 1, 2, 3. So please draw those 3 fraction lines for me. And when we get to the end of this, we're essentially done. Okay, now we're gonna worry first about the labels. We're not gonna worry about the numbers till later. This is a good way to do it because it helps. We can just use our plan. So look at what we're doing. We're going from C5H12 grams to moles of it. Okay, I want to make the grams cancel. So where do I put the grams here? Grams of C5H12. Do I put that same label top or bottom to make it cancel? Where am I going to put this to get rid of it in this fraction? Will I put it on the top or bottom of this fraction? Where will I put grams of C5H12 to make it cancel out? Super. Thank you, Jonathan, Stephen, and Lisa. I do. I put it on the bottom. So grams of C5H12. Now, I show that it's canceling, but I put a little line here. Boop. Okay, it's gone. And then what I want is moles of C5H12. How do I know that? Because it's in my plan. So look at that. I got moles of it. Okay, we're done with our 2 labels. Let's go to the next one. Now I want to get rid of moles of C5H12, and of course I got to put that on the bottom. C5H12. Now I'm using my second arrow. So check out my plan. Oh, and I want what on top? I want moles of CO2. How do I know? Because that's in my plan. I'm going from this one to this one. Last step. Now I've got to go from moles back to grams. This time it's moles of CO2. Here, let me catch up. My moles of C5H12 cancel, so I'm going to put a line through here and here. So now I got moles of CO2 left, and I want to get rid of that label, so I'm going to put it down below. See, this is why you guys are learning some algebra in math class, because it works in chemistry. I bet you wondered why you were learning that. That's why. So moles of CO2. And now that's gone. And what's my final label up on top, just so I know you're following? What's going to go right here as my final label? And Tully has it. Let's see if some others catch up. You're quick, Tully. My final label I want is not the number, Jonathan, just the label. Grams of CO2. Okay. To be honest, that's the hardest part. Now let's go back and fill in the numbers, but that I guarantee all of you can do, okay? All right, stay with me. Here's how we do it. The 422 is our starting number. That's the grams of pentane, C5H12. That's the only time I use the 422. That's done. The other stuff I got to look up. Okay, so we did this a couple of weeks ago. We found molar masses. You're going to have to do this with me. I need you to figure out the molar mass. So for 1 mole of C5H12, how many grams of it? I'll help you do that because it's been a little bit. So we need the molar mass of C5H12. Okay, ready? You need your periodic table. Remember doing this? Well, carbon is 12.0. Remember that for its mass for a mole of carbon, 12.0. But I got 5 of them, so I'm going to go 5 times 12.0 plus H. H is really small. You know that one. It's 1, right? 1.0. So I got 12 times 1.0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0 60.0, and 12 times 1 is 12. And I bet you can add those two together for me. So that's going to be what? See if somebody has it already. You remember getting molar masses? I hope so, because you're going to have to do that with confidence for a gram-gram problem like this. So let me back up. So I had 5 times carbon, 5 carbons, 5 times 12 is a carbon, right? Using my periodic table. And 12 times 1, 12 hydrogens. So that's C, and this is H. Okay, so I got to add up 60 plus 12 is 72. Thank you, everybody. We're going to round that to 72.0. And that's our bottom number, 72.0. You might say, Mr. Weiss, how do I know it goes on the bottom? Here's why. Whenever I look up a molar mass, the number of moles is always 1. And you might say, well, what if it was 5 or something up here? No. When I look up a molar mass, it's always the grams per 1 mole. In fact, I'm going to look up another one later. Watch this. I'm going to look up CO2 later. That's also going to be 1 mole. So we can put a 1 there already waiting for us. But we'll get to that in a second. Good. Let's go on. Okay. Now, the middle part is really easy because you've already done it. It's a mole-mole problem. So every gram-gram problem has a cute little mole-mole problem in the middle. So now let's look up at our balanced reaction. What's on top? What's on the bottom? I got moles CO2 on top, moles of C5H12 on the bottom. So can everybody tell me what number goes on top? What goes on the bottom for this middle fraction? So how many moles of CO2? How many moles of C5H12? So you're going to give me 2 numbers. And thanks, David, Keanu, and everybody for participating there. That 72 is correct. You got it. Thank you, UCN, Lisa, and others are probably going to be getting there. I'm going to go to the balanced equation. Moles of CO2, 5. Moles of C5H12, there's no number there, so we're going to assume it's a 1. Thank you, everybody. Brooks had that, as did Julius, Jonathan, Marino. Thank you for participating. We're coming right down to the end, aren't we? Right down to the end. Okay, last one. Last one to fill in the numbers. Okay, here we go. We got to look up the molar mass of CO2. And I'll do that over at the side here. So CO2, we already did the molar mass of C5H12. That's a lot harder. Well, C we know is 12. 12.0 carbon. Oxygen, what's an oxygen worth these days, huh? How about it? 16.0. So I got 16.0 times 2 because it's O2. So that's going to be 32. I know I'm running out of room here. Plus 12 equals 44.0 grams. I'm sorry that's so small. Let me read what I put here. A carbon is 12. 2 O's are 32. 12 plus 32, 44. 44. Thank you. Lisa had that, and probably some others too. So let's go ahead and put it in here. So 44.0, that's my mass of 1 mole of CO2. You might say, but Mr. Weiss, it's 5 moles of CO2. No. We only use the 5 where it's mole to mole, that ratio. That's the only time we use it. For looking up the molar mass, it's always 1 mole. Back here, 1 mole of pentane. Here it's 1 mole of CO2, 44.0. Okay, now grab your calculator. I've got to multiply all the numbers on top of the fractions and divide by any numbers on the bottom, unless they're ones. Ones we can skip, right? So it's going to be what? 422 times, 1 times 5 times 44 equals, and then I got to divide, those two are ones, I don't care, divide by 72. Can everybody do that and let me know what you get? So in other words, we need a final answer. I'm almost run out of room, but I bet I can fit it right here. So please grab your calculator and punch that out. All the numbers on top, multiply. Divide by any number on the bottom. For us, that's only one number. So 422 times 5 times 44 equals blah, 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 divided by 72 equals blah, 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 blah. And let's see if we can get an answer. I'm going to write here equals blah, 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 and then we'll fill in the number and label together. Yeah, it should be a big number. Good, I'm getting some answers coming in. I got from Stephanie Brooks, UCN, Emelina. It looks like people are agreeing. So it looks like it's 1289, 89 point. And we're going to go to the tens place because we went to the tens place for our molar masses. So 0.4. So let's round it the way Julius did and a couple others, okay? All right, let's see if I got the number right. 1289.4. Yeah, good. And then what's our label on it? What label is left over? It's 1289.4 what? In chemistry, the labels are a big deal. For my German colleagues too, by the way. It's not just an American thing. So 1289.4 what? Look at the problem. What's left over? What's the only label not crossed out? The only label not crossed out. Whoa, look at the time. Time flies when you're having fun, huh? Whew. Thank you. Super. Tully, Emelina's got it. Stephanie, Lisa, UCN, Tilly. It's right. It's grams of CO2. Now, I can't just say grams. A couple of you just said grams. I got to tell grams of what? Because I got 4 chemicals here. So I got to be kind of specific. So let's think about that. So if I burn about a little less than half a kilogram of this stuff, I make a lot of CO2, well over a kilogram of CO2. That'd be 1 kilogram and 289.4 grams, right? You know that 1,000 is a kilogram. You know that. Okay, yeah, you know that. Okay. Questions from you. Let me pause here. Anything you want to ask about where I got this or where I got that for doing this gram problem. Now, I know you have the Stanford test, okay? But I'd still like for you to try 2 of these. So I'm going to give you an equation and ask you to try 2 gram problems for your homework, okay? That's all I'm going to do. It shouldn't take you real long, but let me just pause here again. Use this as your guide. The way I want you to do the 2 problems I send you is exactly like this. I'd like you to do a plan because you're still learning, and I'd like you to do this. So you can put a box around that whole thing. And this is going to be like the homework. So I'll say here, in homework. They take a while, gram problems. That's why I'm only going to give you 2. Okay? All right, let me look and see if I got questions. Stephanie likes the mole problems better than the gram. I do too. They're a lot shorter, Stephanie. You know, the only problem is in the real world, things come in grams and we have to weigh chemicals. Like I weighed out some chemicals for my AP Chem class yesterday. I had to weigh it out in grams. There's no scale that weighs in moles. So you're kind of stuck. Most of real life is gram problems. Bummer. Okay, good. I'm going to stop there because we're done for the day. So unless you got other questions, I'm not going to do any more with you because we wouldn't be able to finish up another one. Okay. Any last questions from you? Thanks for the great participation. I hope you understood it. And I hope you stay healthy and wealthy. No, at least healthy, and and you do well on the Stanford test. Okay, and I will hope to see you again someday. But I'll send you a couple of gram problems as a little present for you to try. Okay, goodbye.